Awesome. Happy Tuesday, everybody. And I'm super excited to have a couple of amazing demos today. I saw a message in chat about just like, will there be repos to share? And I think a lot of the things that are going to be demoed are open source, actually. And so we can definitely share those as the demos go along. So let me just share my screen to kick things off. And before too long, I'll make sure we switch over to demos. And so just a quick thing about the MCP-agent Silsila series. Our goal really is to create a space for engineers and developers to learn about MCP and about agent development. We want to try to break through the noise and really focus on technical details and have a space just like, we can talk about the details. And especially about how we build AI applications, because that's changing rapidly, especially in the past year. And also the goal is to actually shine the spotlight on you. We're not trying to create this as a space for any selling a product or like promoting a single company. It should be about cool things that people are building, especially with MCP and agents. And so if you have things that you want to demo, just reach out to me or Hanye, and we'll make sure to include you in the next webinar. Also, I mention this every time, but quickly, like Silsila just means a chain of events in Urdu. And so I thought it was a fitting name for a gathering of builders and researchers and developers, and especially as it relates to building agents that are powered by MCP. So we have an amazing panel of speakers today. We're probably going to go in the order described here. I'm Sarmad. I'm one of the co-founders at LastMile AI, and we've been building a lot in the MCP space, and I'll share a little bit about that. But really, I want to focus on some of the amazing presenters today. So first, Roy will kick us off from IBM. He is going to show MCP agents as servers using Langflow, which is a popular project from IBM. Then we'll switch over to Noah from Tavily, who's going to talk about how MCP is being used at Tavily and with Tavily. Arjun will have a quick presentation as well, and then we'll have like Q&A over the course of like each of these sessions. And so without further ado, maybe Roy, do you want to kick things off? I'll stop sharing so you can go ahead.
Perfect. Thank you. Great to see everyone. So let me share my screen. Okay, so I believe you can see my screen now. So I'm going to talk a little bit about Langflow, which is a open source library to build AI applications and agents and flows and all those kind of things. It's fully open source, so everyone can sign up. Well, you don't have to sign up. Everyone can download it and use it on their local machine, or you can actually sign up for a desktop version. It it's one of those flow builders. You maybe have seen other projects that are allowing you to build flows to do certain things, and that's what I'm going to show you today as well. It's all Python based, so if you want to touch any of the code, you can do so. You don't have to, but you can actually touch the code in case you want to. And here are a couple of links. We recently reached 100K stars, which was kind of big. I think we're almost at 120 now. So that's really great to see. So it just shows a lot of developers are using this to build their flows, to build their agents, and more recently also build their MCP servers. So what I want to show in this demo mostly is how you can use Langflow to turn flows, which is a sequence of certain actions, into an MCP server, and then consume that in an agent as well. Could be an agent you build in Langflow, could be a coding agent you're running in Cursor, could be an agent you build in a random library somewhere and host it on your own servers. So it can basically be anything. So why MCP? I think a lot of these tool builders, they're relying on tools. Something I don't really like is having to build your own tools every time again, no matter what framework you're using, no matter what visual builder you might be using. Every time you want to interact with a tool, which could be an API or a database or some SaaS service running somewhere on the internet, I kind of like it don't having to not having to rewrite my own logic every time and having to bring my Python or my JavaScript code to all the different frameworks. So in Langflow, we're making a big bet on MCP being the way people use tools. And it also works two ways. So you can bring in MCP servers from all over the internet and connect them to Langflow and start building your flows and agents. Or you can expose what you're already doing in Langflow by building flows and agents as an MCP server and then bring it into any of these agentic frameworks or even your IDE or basically any place where you would connect to MCP servers. So for this, I think you can still see my screen, right? I never really know if I start to switch tabs.
Yeah, we can see it.
Great. So I have a couple of demos in here. What I want to show today is a YouTube analysis flow. You can build all sorts of flows with all sorts of things. You can connect agents, models, data sources. We have Tavily here today. I'm pretty sure there's a Tavily here as well, so you can actually use Tavily for extraction or search. I'm not going to do that in this demo, but you could. So what I have here is a flow to look at a YouTube video. And I'm trying to make this a bit bigger without losing the overview. So I have a chat input. So basically I can connect this to a chat interface and I can give input text like a YouTube video URL. I then have a step that's going to use the YouTube API to extract comments. I then have a batch run, which is going to connect to a large language model to inject all these comments and sort of going to get some sort of sentiment analysis. I'm using IBM Watson XAI as a model input here, but I can use all sorts of model inputs. I can get models from basically a lot of different places like OpenAI, Anthropic, Google. I can also build my own components in case I have another provider like IBM. It's then going to parse some things. So there are a lot of steps in here. And finally, it's also going to take some transcripts from the YouTube video, again, using the same YouTube API. It's going to construct a prompt for me. And finally, somewhere here, it's going to be passed on to an agent. So the agent has a prompt, which is basically extract the transcripts using all these different tools we have, process sentiment, create comprehensive analysis, a lot of different steps. So if you're doing context engineering, you're probably used to constructing all these different steps for all your agents. And finally, it's going to have an output. So this is a flow to extract comments and information like transcript from YouTube, and finally providing you with some output. I can test this flow. I think I already did it, but let me delete this and just start a new session. Basically, all I need is a YouTube video URL. I think I had one in the beginning here. Let me just copy this one and go here. I basically input this video URL, and then this flow is going to execute, and this flow is going to get the comments, it's going to get the transcript, and finally you're going to get some information on this video. I think this video is called, it's discussing DeepSeek and how you use DeepSeek as a large language model for a RAG pipeline. And you can also see the input video URL and then basically all the steps being taken. So this is a flow you can build. You can execute it right here. What's probably more interesting is executing this as an MCP server. There are multiple ways you can do this. You can actually take this JSON and it's running locally on my machine in this case, and you can connect it to basically any place where you would connect MCP servers. You can also auto install in Cursor or Windsurf or any of those in case that's what you want to do. What I'm going to do now actually is I'm not going to consume it in any of these external systems. I'm going to consume it straight into Langflow, because in Langflow I can build agents as well. Always fun getting errors. So I'm not sure if this is going to run, but let's see. So I have an agent here again. It's a very simple agent. It's a helpful assistant that's going to do some things for me. I have it connected to a model, and then I have it connected to MCP tools. So these are basically MCP servers. So I have a couple of MCP servers connected, but the one I'm using here is actually my Langflow. So I can connect this again. So all the projects I have in Langflow, I can use them as MCP tools and then connect them to an agent. And I can also bring in more different tools like the YouTube search here. I could have used the YouTube MCP server, and probably if I do this demo again, I should. I'm connecting both of these to an agent, and then I'm going to get chat output again. So if I run this in a new one, I can actually first start to search for videos. So find videos about MCP and return their URL and title. It's first going to use the YouTube search tool, like searching videos. It should give me a list of videos, including their URL. And then I should be able to ask a follow-up question, which is going to use my MCP server, which is basically my flow to analyze a YouTube video, to analyze the first video and see what it does. So it is calling this YouTube video with the input value, which is this URL, or it should be. And then it's going to provide a sentiment analysis. I'm not really sure if this is about MCP, actually. It might be about, oh, it is about MCP. So there's some hallucination in here because it talks about MCP being machine code processor. So you probably have to double click and see what is happening there. So some hallucination, but you can see the steps, right? It's using the search first, and then it's going to call my second tool, which is actually coming from my Langflow MCP server. So this shows how Langflow is both an agent builder, but also a place where you can build flows and turn flows into MCP servers. So there's much more I can show here. You can also check out the project yourself, basically by going to GitHub and search for Langflow. We have a couple of new things coming up in here as well. So there's going to be OAuth support for all the different MCP servers. For this, basically, we built a new library called MCP Composer, which is an open source library to secure and compose MCP servers. And then at IBM itself, we're building all sort of MCP servers. So you can also find some of these here. Maybe some of you are using IBM products, or maybe you're not. It's at least cool to see how we're using different technologies, and most of all, how IBM products are jumping on building MCP servers at a rapid pace. So I guess that's it for me. I see some questions in the chat. Do we want to do this after or right now?
Let's do them now, actually. I have a few questions myself, and thank you a lot for the demo. This is pretty interesting. So let me read it out. So Aditya mentioned, if it's exposed as an MCP server, how does it maintain sessions in memory?
That's a good question. So it depends how you use it. I'm using it all locally. So it basically means it is building session and memory on my machine. I don't think that's something you want to bring into production. So if you were to host this Python code yourself, you would have to set up some things in order to maintain memory and state here. If you would look at the playground, actually, you can see there are ways to maintain state. So you can see my chat being stored here. So if you run all of this locally, you basically have the same things running on your machine. You probably, and this is something I personally like, take some MCP servers to store things in memory and put them in one of your flows. That would be my recommendation, because then you have more control. Otherwise, it's all buried somewhere in the Python code that we compile.
Right. And then Kumsal asked, can it use models from Olama?
Yes, you can do all sorts of things here. You can do something called, I'm not sure if you'll find it like here, but you can bring in custom
Nice.
components, but you can also bring in Olama, for example, through here. So this only works, of course, if you're running things locally. If you decide to deploy this Python code at some point, you're going to have models running somewhere. I wouldn't recommend hosting your own models, though. So you probably want to connect some external provider for that.
That makes sense. And then Charles asked, for the local case, what are you using flows as MCP servers for? What's the use case? And what have you tried that has proven to work, and also not what doesn't work?
So what I kind of like, and this will turn more into like a philosophical discussion. My main problem with MCP is, or tool calling in general with most agents is it's hard to go to something deterministic. So we're all building software. And for us, it's evident if you have a function that does X, Y, and Z and it calls another function, it's going to execute things in the same order. So my general problem with building agents that are doing tool calling is if I have a set of tools that I like to get called by the agent in a specific order, I can use context engineering and put things in my prompt to steer the model towards that action. But it's not going to do all of this every time in the same order
No.
I want it to actually happen. So I like to take different tools from MCP servers and connect them as flows. So I have some deterministic behavior in there and I'm able to direct how tools are being executed and in what order. There are MCP
Yeah,
servers to do this as well, but I like to build them as flows.
that makes sense. I had a general question actually about Langflow and who you see as like the target persona for building some of these flows in the visual way, and how you would compare that to like, just building similar logic through code. How do you kind of like differentiate those things from a product perspective?
Yeah. Yeah, that's a great question. So I have a long history in web development. I like to build web applications. I think if you like to build web applications, a visual tool like this is great for building your quote unquote backend. I wouldn't really
Hmm.
call this a backend, but it's almost like your API because what you get here turns into an MCP server or it turns into an open API compliant endpoint. So there are multiple things you can do here that serves as your backend. And then as the web developer, you're able to build your web application that connects to it.
Hmm.
On the other hand, if you're not able to write code for whatever reason, this is a great tool to build agentic behavior. And you can just use
Yeah.
this playground to interact with the model, interact with flows, all through a single interface. So I think it serves both developers that are building solutions on top of AI, but also people that have no clue about writing code.
No. Absolutely. All right, we'll take one more question and then move on to Noah as well. So Zach asks, how does Langflow compare to something like N8N or running an MCP server in Claude and Cursor? Is there something Langflow can do that you can't do with those tools?
So I think N8N is quite comparable. Um, Maybe on the website, I'm not sure. We used to have a place on the website, I think, where you can compare both. There's some small changes, but in general, I'd say these are pretty comparable tools. On the
Hmm.
second, so what Claude and Cursor do, you can connect MCP servers, and that's fine. But if you want to build agentic flows, you can build your agentic flows in here and expose them as an MCP server
Hmm.
like this. And then you can bring those into Cursor or into Cloud or into other places where you might be consuming MCP.
Right.
So N8N is pretty comparable. There's some small nuances that might be different, but compared to Cursor and Cloud, and here you can build MCP servers and create them, and then bring them into your IDE and start interacting with them.
Awesome. Well, thank you so much, Roy. And I think there's still plenty of questions coming in, so that shows how exciting your presentation was. So maybe we can move the rest of the Q&A into chat. And I'd love to invite Noah to talk about Tavily a little bit.
Perfect. Thank you.
Thank you.
Okay, so hi everyone, I'm Noah. I'm a forward deployed engineer at Tavily. And yeah, I'm just here to talk about kind of the state of AI, what's happened in the past few years, how Tavily plays a part in that, how MCP plays a part, and just kind of shed some light on building these AI agentic systems. So let's reflect. First, LLMs in 2023 came in, and they provided us these amazing decision makers that can think logically and make decisions with informed context. But RAG acknowledged that yes, LLM calls are great. They can give you a response really quickly. Oftentimes they're a good response, but usually in a real use case, it needs data. We need relevant data to prompt our LLMs to make this decision. And what RAG does a great job of is using your collection of data, finding the semantic meaning and the most relevant data in that data set and providing that to an LLM call. So moving into 2025, now we have these bigger applications, these bigger problems we want to be able to tackle with our LLMs and having them act autonomously and on their own. And that's where agents come into play. And what is an agent? So agents are these systems that work autonomously, given tools and prompts to work on these bigger problems. And the most common and practical example of this is a React agent. So as you can see the diagram here, you can think of a React agent as a recursive loop where your agent uses the tools to complete some task like research. And the base case or stop condition is when the LLM decides it has enough information. This is pretty simple concept to think about, but it's very valuable system that you can build, right? It doesn't have the same shortcoming of building a fixed system, because if you fix a workflow into your code, it might fail. It might fail after one tool call that you've defined it to be. Maybe you add a second one because you see it's not performing, but you're always going to hit that wall of something that you didn't think of when you were building it. So what the React agent does is it makes the tool call. It looks, hey, do we have enough information to give the final response? If not, maybe it makes another tool call. Maybe it tries something completely different. And once it decides it has enough, then it gives the response. So why do we have to think about this? And it's a good question. Early systems typically underperformed, right? If you think of a sales agent with no up-to-date knowledge, right? You're not going to you want your reps to be well informed when they go into a meeting. And this because, as we spoke about, models are really good decision makers, and they function just like humans do. They rely on what they know, the data they were trained on, and they make decisions by recalling relevant information. Prompting can help steer this in the right direction, but it's not sufficient for producing these like expert level, production ready, and reliable outputs. Even with React, if we're not providing it the right tools, it can't come to the best conclusion. This is especially true in complex or evolving domains, requiring like consistent refresh and consistent research and information refresh. Think of financial markets that are constantly evolving, and healthcare where there's new research being discovered every day. Context engineering is how we optimize this sort of data flow in and out of our agents and AI systems. So if someone were writing a report, think about it like this. They wouldn't rely solely on their memory. They'd gather sources, extract the most relevant facts, and then organize them for easy reference. And that's sort of how this context engineering and building these well-maintained and scalable, production-ready agentic systems can work. Ultimately, accurate agents need to access tools and be directed to properly use them and retrieve the right information. So I strongly recommend when you're going out and building these agentic systems that you think about, if you were the person making the decision rather than the LLM, what information would you need, right? Where would you need to gather information? Maybe it's data from the web. Maybe it's data from your CRM. Maybe it's data that you have in your database. And you think about everything you need and you mimic that in the code. And if we think about how LLMs are kind of static and the world is constantly changing, foundation models, right, they face limitations from training data cutoffs, insufficient domain-specific optimizations, and they don't have the access to real-time information. And since we discussed, like, we want to optimize for the context in each moment of time, from when you call your agent, you don't want it to have the context from 2 months, even a week, even a couple days or hours can be stale. So we want to kind of be able to keep our agents up to date and merge the gap with context. So what we believe at Tavily is what's missing from a lot of this real-time data, what's missing from a lot of these agents is real-time data. And what we built is a tool where your agent can retrieve data from the web in multiple ways. And I can go through that in a little bit. But ultimately, if your agent is lacking context from your databases or something else, or your CRM or wherever it's grabbing from, it doesn't just hallucinate the response, but instead goes out, retrieves the relevant information from the web, and fills that gap. So at Tavily, what we have built is the bridge between the web and your applications. So search is the first endpoint. Search is our bread and butter. We retrieve the most relevant real-time data from the web and package the most important details from that web page into digestible chunks for your agents and RAG applications. This is all done in a couple seconds. Extract allows you to scrape data from many URLs in one go and retrieve the full web page context. Our crawl endpoint provides a base URL to create a map of all the URLs on the web page and recursively goes through each page, clicks the links on all the page, and uncovers all the data, creating a map from all the URLs to the content. And you're able to provide natural language instructions telling it to look for specific things on these web pages. And we've also built our MCP server so developers can easily load the Tavily web search, extract tooling into their systems. So the point is with Tavily, and now your agents that act autonomously are aware of the whole context and they don't have gaps in their knowledge. And here's a video of this chatbot that we built, and it just does a really good job of showing. So see, we needed to do a web search to get the recent news in New York, and we have that summarized. Another use case we built is a market researcher agent, where you provide it the stocks that you want, and it goes out and performs these like big in-depth reports on each one. And that's for both news and financial data. So the MCP Model Context Protocol is an open standard. It enables AI systems to interact seamlessly with various data sources and tools. Tavily MCP provides AI models with real-time access to web information, complete with sophisticated filtering options and domain-specific search features. You can connect to our MCP in two ways, one being our remote MCP, where you can set up a client either on Langflow, Agent Core, LangChain, or locally through Claude Code or Cursor. And you can see in this video, this is how we kind of go through this, and this is the URL for a remote MCP.
Awesome.
So what's next and why MCP? As tasks become more complex, like one LLM or agent lacks in its ability to solve these complex problems, it's important to decompose these tasks into subtasks and delegate separate sub-agents for each, specialized with the necessary tools, prompting, and separate context windows, which will allow your systems to problem solve at a much higher level. And I just want to highlight the importance of keeping the context windows separate when you're building these multi-agent systems, because we don't want context leakage from one into another. So if there's unnecessary context in one, it pollutes the answer, can cause tool calls for unnecessary data for that subtask, etc. So I just want to urge to keep these sub-agents modular. And this leads into packaging agents as MCPs and as servers that we can have each agent interact seamlessly and easy to use. Yeah, I strongly encourage everyone to experiment and build these RAG agents, multi-agent systems on your own and create like really strong opinions on how these systems work. It's uncharted territories for even researchers these days. So I think it's really important that everyone keeps strong opinions and debates these things. Yeah, so thank you.
Awesome. Thank you, Noah. All right, let's see if there are any questions. I think there are a few general questions around MCP, which we can probably discuss towards the end. But one question from Daniel is, what's the differentiator of Tavily versus other products in a similar category?
Yeah, so what Tavily does really well is we bridge your AI applications, your agents to the web. And there are some other products that do this, but what we do, I would say even better, is we have our proprietary kind of backend and scoring and relevancy mechanisms that make sure that you're not only getting the relevant information from the web, but you're getting the relevant chunks and the relevant data from that page. So there's different ways to interact with our API to optimize that. And we also provide a lot of customizability to developers. If you want to kind of take as much responsibility for building these systems, you can do that. You can also use our auto parameters, which will infer based off of the context how to properly call our API. But we aim to provide developers with a lot of kind of open source code they can interact with. We're big in the open source community, and the customizability to tailor it to your workflow.
Awesome. All right, and I think we can continue just in the interest of time over chat, perhaps, for additional questions. I did want to chat a little bit. Maybe I'll get your thoughts about this, Noah, as a parting thought. Arvind asked, what are the disadvantages of MCP and what are the gaps? So perhaps like from Tavilly's work on integrating with MCP, what do you have any thoughts on the gaps that MCP has at the moment?
Yeah, so an MCP server is kind of treated as a black box, right? It's how you interact with these tools. You don't have control over like some of the parameters and prompting that you're doing. That's kind of going on behind the scenes. So you leave it up to us, you leave it up to Claude Code to decide how to interact with these tools. I think that's one disadvantage for some production level applications. Maybe you want that very like fine-grained tool calling built into your applications. What it does really well is ease of use and being able to get access to all of our tooling by just quickly setting up a client, being able to plug it into your current flows. Yeah, so it's just a matter of how much you want to kind of build yourself versus the ease of use.
Yeah. How do you think about like human in the loop, by the way, for some of this? You mentioned MCP servers are kind of a black box, and I know they're like new APIs like elicitation for servers asking the client for information as needed or accept decline kind of requests. Have you integrated some of that into Tavilly's MCP server yet?
Some human in the loop.
Yeah, like elicitation or some of these newer APIs that are coming out.
We haven't integrated the human in the loop into our MCP.
Yeah.
I think the way we see customers typically use it is just retrieving the best content
Right.
from the web and based off of the context. So yeah, I could see it like a system, a full like agentic system that uses our MCP. Human in the loop could definitely be something valuable to include to make sure like the data
Right.
and things like that. Things like in a open deep research.
Yeah, absolutely. Awesome. Well, thank you so much. And one perhaps like Hanya, do we have Arjun here to give a quick demo, or should we continue?
Yes, he's here.
Awesome.
Arjun.
Yeah.
All right, Arjun, go ahead.
Hey, so I'm unable to start the video.
Can you do it now?
Okay.
Yes.
Hi guys, I'm Arjun. So I'm co-founder of Retriever AI. So I can just quickly share the screen. So hopefully you can see the screen. And what I wanted to demo is that we are rtrvr.ai. We're an AI web agent, Chrome extension that can do actions in your browser. And we're launching a new API, cloud, and MCP platform that is coming up. But just to give a quick demo of the capabilities, like in the previous version of the Chrome extension, we do agentic actions in the web, in your browser. So it'd be like go to LinkedIn and add what was Saad or I could add Hania. I think I'm already connected with Hania. Sarmad Qadri, right? On LinkedIn as a hopefully I spelled your name right, but otherwise the agent can figure it out. But so basically, it's an agent that can go take actions on the web, and our main use cases is like filling out forms and retrieving structured data to Google Sheets. But yeah, it can type, click, do all the actions in your browser that you would normally do. And so a lot of use cases were like, hey, go fill out these health insurance forms and retrieve all of these various quotes or like, hey, go to all these trucking companies' websites, fill out like these from to locations and get all these quotes. And then I have a data set that I can use for my own agent. So I think it was just my fault of Whoops, I kind of interacted, but that was my fault of like having selected text. But yeah, so while retriever takes actions on your own browser, like you can let it run in the background and do the task, and it can even do tasks across multiple pages. And yeah, so I think it's typing into like, so you can give feedback at any time, and like connect. So I usually do this demo. There's never any failure, but like while it wraps up on here, I could give another use case where we have our agent go like give a simple prompt of, hey, use this API key on the screen to create a tool to load contacts to HubSpot. Then go to LinkedIn, go find my recent connections, and load those connections to HubSpot. So like gave this simple prompt, and with that prompt you're using all using Gemini Flash, you're using all the basic capabilities of code generation, structured data extraction, and tool calling to take actions on the web, create tools dynamically and use them. So it went to LinkedIn, it's found my recent connections, and then it opened them in parallel to get their contact info. So it's like in all of them in parallel, it's getting the contact info for all of these connections, and it's writing it to Google Sheet, and so so it has something do the tool call, leverage the tool that we just created to load connections.
Hey, Arjun, I think you're
But
getting
yeah,
cut quite a bit. Do you want to, do you
oh
mind like
sorry,
just repeating
I
maybe
I
the
was just
last
running low on
15
battery.
seconds?
Oh,
Yeah, that's okay.
okay.
You can also like maybe message in
I think,
chat
yeah, I think
with a
it's
link to the
okay.
YouTube video. Maybe in the interest of
Yeah.
time, we can move over to chat as
I'll
well.
do like a quick the new thing. So like to
Are you presenting? Yes.
yeah,
Sorry.
yeah, lots of
Go ahead, Bhavani. Let's do this, Bhavani. If you don't mind, maybe we can switch this to the like you can post the YouTube link in the chat as well. But if you want to do a very quick demo, maybe you can just show really quickly.
yeah,
But
sure. So for example, so the latest version of Retriever is Retriever. You can manage Retriever through our MCP endpoint. So I added Retriever MCP endpoint in like Claude, and I'm asking Claude to just craft me a post and make a post on my LinkedIn. So it crafted a post, and whenever it needs a web agent, it sent the request to Retriever MCP endpoint, which took care of like distributing that to wherever you install Retriever on. So like you're on Claude, your ChatGPT, all you have to do is give Retriever MCP endpoint here, which we'll share shortly. And then it will, we expose a bunch of tools for any like MCP client as such. So it's like automatically like I asked about creating like an AI post about like agents, state of the AI. It went into my LinkedIn, made all these content and should like post it successfully in like no time. So Retriever Act 1, the Arjun was trying to show with the demo, is an extension that runs on your machine, does automation end to end, while also like scraping data like end to end. Like one of the examples in the chart is like, yeah, like I know the pain of like going through thousands of tech events and RSVPing them manually. That's why we use Retriever of like, go to these tech events. I'm like a tech founder, rank me or like filter the events that I should go, yes or no. And then for the things that are yes, like automatically RSVP. So it goes to the link, it fills all your details. You can dump as much context as possible into Retriever and make things happen. So earlier it was just an extension that you can talk to, but now with like Retriever, like the second version that we'll be launching soon, you can distribute tasks across a bunch of your devices just with our MCP endpoint and put it in your, if you want control in your own script, you can use our API endpoint directly and manage everything end to end.
awesome. I'm curious, the MCP server that you showed, is that connecting to like the extension? So is it running locally?
Yeah, so the MCP
okay.
server is in our production. It's not running locally. Whenever you install Retriever and like sign into the Retriever, we take care of like registering your extensions and yeah. So like we manage. So as you can see here, it's like a production endpoint of like Retriever web agent here. And whenever you install extension on whatever device, we'll make sure of like registering them and distributing them. So our MCP server distributes it to all of the extensions that's under your profile or your account and like distributes the task across your device. So we'll take care of that.
Awesome. I love it. And best of luck with this. This is a very exciting project as well. Sweet. And I think it also dovetails nicely into, I think, how computers in general are changing, where we're becoming more like directors, and there are all these little agents that are actors that do stuff, interesting things on our behalf. And this is a very nice example of, like, in my mind, an MCP server that is very agentic in nature. It's doing some fairly sophisticated workflows behind the scene. So yeah, very exciting user interface. How does it compare to, I think there's I forget the name of the company, but there's a tool called Scout, which kind of like, does web scraping and kind of like a modern way of doing Google Alerts. Have you thought about like the feature set difference across the two?
Yeah, I think Scout is more of a like it has a full desktop. Sorry, we were right next to each other, but yeah, it has a full desktop, and we're just trying to do like only DOM processing. Like basically, our secret sauce is constructing a way of representing HTML to a tree to LLM, so we don't need anything to be rendered. We don't need to draw these bounding boxes that all of these other web agents are doing. So it's like the underlying technique that we do allows us to be serverless, allows to be headless, and allows us to just use the HTML to do page actions.
Yeah, and also
I
we
see.
benchmarked us on like WebBench, the latest open source benchmarking, and we are the state of the art with 81% success rate, even beating OpenAI, Anthropic browser use and whatnot. Yeah, we will paste the link, Daniel. And yeah, we reached 10,000 users with extension using various amounts of like insane automation that you can do of like sending message to the followers of your competitors on TikTok, Instagram, or like your lead generation automation on like LinkedIn, Crunchbase, what everything end to end. But we wanna like provide interface of like through our website and cloud offering. That's why we're gonna like relaunch it. Yeah.
Yeah, and quickly,
Awesome.
so we're really excited for this new Chrome web agent as MCP server. So we are really looking for people to partner with us. So we think there's a whole world of website integrations you can do that are on the front end side. Like say you have a agent or website that you generate content to post on LinkedIn, you can just like have your user paste our MCP server URL, and now your website can open the user's LinkedIn profile and post on the user's own browser. So you don't need any LinkedIn to API or anything. So like another alternative is like Plaid. Like instead of like integrating with Plaid on the back end, we can open like users' bank accounts on the websites on the browser and retrieve that data for you. So there's a whole world of new web agentic integrations that are available. And if you're really excited to partner in the future, please reach out to us.
All right. And I think that was an excellent set of discussions, and I think there will be continued discussions over chat. I just wanted to share one last thing with folks, which we've been working on for several months now. And so we're just about to like launch this, and so I'm very excited to talk about it. Let me share my screen, and I'll take like maybe 10 minutes of folks' time to go over this. And so the theme that we've been talking about of AI agents as MCP servers, I shared some of these slides last time as well, but let me give a little bit more context. So if you think about agents today, a lot of the agentic behavior happens on the client side. So the client may be a Cursor or a Claude Code, or now there's OpenAI Codex, and those are the applications that do the agentic behavior, and then they connect to MCP servers to get to call tools, to get data, even to like get prompts and resources, etc. But like you could actually expose agents as MCP servers instead. That way, any MCP client could invoke these agents and coordinate across them and orchestrate them just the same way that it does with any other MCP server. And that's kind of like the idea that we've been thinking about quite a bit. Roy showed that with Langflow as well, where you have these agents themselves exposed over the MCP protocol. And so you can even do like these multi-agent interactions over the same base protocol that like you do to fetch data. Tavily is more of like a retriever. And so there's, it's fetching data from the web. It's doing more of a prototypical kind of like API request. And then retriever, I think that we just saw, that to me also seems like an agent that's exposed as an MCP server, because you make these tool calls and then the server goes out and does like sophisticated things behind the scenes. And those sophisticated things may involve LLM calls in that workflow. And so the other thing that we've been thinking a lot about is tools currently in MCP are pretty short-lived. Like they're in proc, right? You kind of call a tool and then you await for its response. And so they don't really work very well for agentic behavior, because agents can take minutes to hours to maybe in the future even days to complete. And so how do you like model that as a tool? How do you pause and resume? And how do you like, what's the runtime of the environment of this? Because they can't just like block the server on an API call that's going to take hours to complete. And so we've been thinking about modeling these kind of like agent tools as async workflows. And so that like these agents can be paused and resumed, they can await for human feedback, they may fail and need to be retried. And we currently use temporal in the backend to like kind of actually execute the agent runtime. But in order to expose it, one of the things we actually came up with was this decorator called app.tool with an MCP agent. And what it does is it sets up a temporal workflow for you, and it like basically will wrap this API that you have that you want to expose as an MCP tool as a temporal workflow, so that you can kind of call it like any other MCP tool, but it will be executed in an asynchronous, long-running, durable execution backend. And so this part is now like open source. It's available for folks to try. You can run it locally as well. But one of the things that we've been working for quite a while on now is actually being able to deploy these agents as MCP servers in like a single command. And so we've been calling this MCP agent cloud. And really the whole idea is you should be able to deploy agents that you write with MCP agent as SSE or streamable HTTP MCP servers, and for like automatically have these app.tool decorated functions run as long-running temporal workflows. And so agent-to-agent communication, agent to other tool, other MCP server communication, all of that happens over MCP. And all of the execution, because it's durable, it's like fault tolerant, and it can be paused and resumed over long periods of time, happens over temporal. And so that's what we've been working on. And I want to show you a very quick demo of that. So here I have this like project that if you do MCP agent init in using the CLI, you'll be able to get this. And I'll just go over a few of these. So I talked about app.tool. So this is an MCP server that will be exposed through MCP agent. And this tool will actually run in a durable execution backend as a workflow. And so in this case, the agent is very simple. It has access to the fetch and file system servers. It's like a prototypical Hello World agent. And it's just able to like fetch URLs, read files, and answer users' requests. And so this tool will just like, generate, you pass in the input that the user specifies here, and you'll get a response. Then we can like have a regular MCP tool, which doesn't run in the durable execution backend. This is like, you're just calling a simple function that you just want a quick answer back from. So this will run in proc in the MCP server context. And we have a whole set of these things. By the way, like loggers, notifications, elicitation, sampling, all of these really advanced like MCP features, we spent a lot of time just getting all of them to just work seamlessly. So here you could do like logger.error, and this will show up back at the MCP client side as a notification, all done over MCP. So there's really like no secret sauce here. It's just putting together a bunch of these technologies and exposing things in this standardized protocol. And then to deploy this, you can actually like run this locally pretty straightforwardly. and test things out. And there's tons of like examples and documentation in the MCP agent repo for that. But in order to deploy this, you just do run MCP agent deploy. And this one single command will basically get you, I ran this just before starting this, and it gets you like an HTTP endpoint with a deployments.mcp-agent.com URL. And this is an SSE endpoint for your server. And so you can basically run this in Inspector and Claude and any MCP client. And so let's just try that real quick, actually. I think I have it actually set up here. Yep, this is running. And so here, let's just do a list tools request. And you can kind of see all these tools that we had. The Finder tool, which was that Hello World agent that has access to fetch and file system. The cool thing you'll notice is this looks just like an MCP tool, and it is just an MCP tool. But I can like maybe say, please summarize the first paragraph. And we'll use maybe the model context protocol website itself. And so here we'll run this tool. And first you'll start seeing the notifications. These are all the logger statements that are coming back from the server. And so you can immediately start seeing like all of this collaboration and coordination is happening over MCP. We made a tool call where we passed in the arguments, and then we got a response back. And it says something to the effect of the first paragraph of this is this USB-C. I think they compare MCP to the USB-C of analogy, and that looks pretty correct. And so the cool part is this didn't just run in the app server context, it actually ran in temporal. And so you can do all sorts of really sophisticated stuff as a consequence of that. This workflow could have failed. It could have ran for hours. It could have required human input, and the workflow needed to be paused and then resumed at a later date. And all of those semantics are still possible, but they're exposed as an MCP tool. What you'll see also is like some of these tools, there are a few tools that ship by default. So you can kind of see like workflows list shows you all the workflows that you can run with this server. This comes like automatically packaged as part of an MCP server shipped with MCP agent. Workflow runs will show you like all the workflows that you've run and what the status was. And it's really useful for things where they're long running tasks, and the tools will like return a workflow ID so you can kind of query things afterwards asynchronously. And then you can use this also because this is just a streamable HTTP or SSE endpoint. You can just use this in any MCP client like Cursor, Claude Desktop, ChatGPT, etc. And you can start using your agents pretty much anywhere. And so we're pretty excited because this is kind of a new, paradigm for how agents are exposed over the web. And I hope that this results in like many, many more agents that are doing very sophisticated things. And you could write all sorts of custom agents, but then deploy them as MCP servers and then use them in any MCP client. And the fundamental premise is that in the near future, the vast majority of line of business applications are going to become MCP clients. And so if you want custom agentic behavior in those applications, the best way is to just piggyback off of like the MCP protocol and expose your agents as MCP servers so that you can use them in any MCP client. And so that's the simple premise, and there's a ton of infrastructure behind the scenes that makes this possible. So please check it out. You can basically go on mcp-agent.com, and there's some docs on getting started. And we're going to be doing like a pretty soft launch in the coming hours, just posting about it on Discord and Twitter. So check it out, and would love your feedback. Really, like this is a new paradigm, and so we're curious to see what folks do with it. And I'll pause sharing my screen. Let's see if there are any questions I can answer right now. And otherwise, we can like kind of talk about this asynchronously over Discord as well. What do you think, Kanye? Should we end it? We're also at time here, so I don't want to take too long. But yeah, let's, if you don't mind sharing the Discord link, let's have Kevin talk about it and over there. And yeah, very excited for folks to try this out.